So in order to do stepwise regression, then the basic command that you need in each case is step, and then beyond that, stepwise selection and forward selection are very similar, and then backward selection is a bit different. So for stepwise selection and forward selection, so the basic command remains step. This is then applied to the null model. The model is just a constant term, and then for stepwise selection you specify direction equals both. For forward selection, direction equals forward, and then the scope is the formula of the full linear model that you fit. So in this case, for both stepwise selection and for forward selection, it's just formula of a.lm. And again, these names and the layout of this follows from the R commands in the previous slide. And then for backward selection, this is now different. The step command is instead applied to whatever you've called the full regression model, and you specify the direction to be backward. Now it is possible that you might get different answers with different methods, but in the simple example in this lecture with the Longley dataset, all three approaches agree and select a model with the variables x2, x3, x4 and x6. So in this case there's no x5 term, so the indication is that there is some redundancy here and you can have a model without the x5 term. So I just wanted to go over the final solution interpretation then. So multicollinearity and interrelationships between the x variables mean there is some redundancy and the x5 variable is not needed in the model. Okay, this means that the number of people employed just depends on the gross national product, number of unemployed people, the number of people in the armed services, and the time in years. Okay, and beyond this, you've got some confidence that your conclusion is reasonable because you've got three different methods: the stepwise selection, the forward selection, and the backward selection, all pointing to the same model, so all telling you the same thing. So once the stepwise regressions have suggested a model, the basic idea was that you would refit the model just these variables above, so just x2, x3, x4 and x6, and interpret the results. And so the point of this, I just wanted to re-emphasize the R coding and how that works, and the interpretation elements that you might need for a coursework question this year, but for exam questions in other years. So in R, like a robot, so first command, step.lm, just tell R to do the computation and call it something. So this is just going to be a linear model of y depending on these variables here, x2 plus x3 plus x4 plus x6, then a separate summary step to get R to display the results. Results, when you get them in R, look a little bit like this, and the thing to watch for here is that all the useful information is contained in the second row of the table downwards, and then because you've got asterisks at the end, the indication is that all these variables are significant, which is exactly as you would expect as you have applied these stepwise regression models, which will just keep the variables that are statistically significant. So the things to watch out for then, the first variable x2 below the constant term is significant and is negative. So as x2 increases, you would expect the y variable to decrease. The second variable down, x3, is significant precisely because the number at the end, the p-value, is less than 0.05 and it's negative. So again, you would expect that as x3 increases, the y variable decreases. The third variable down, x4, is again significant precisely because the p-value at the end, 0.00180, is less than 0.05 and it's also negative, so this would indicate that as x4 rather increases, the y variable decreases. And then finally the x6 variable is also significant because the p-value at the end is less than 0.05, and because the coefficient is positive, it suggests that as x6 increases, y increases. So just to recap this final interpretation then, and remember what is going on here is that the way you write this down is the opposite way to how you work it out. So the coefficient of x2 is negative and statistically significant. So as the GNP increases, the number employed decreases. The coefficient of x3 is negative and statistically significant. So this indicates that as the number of unemployed increases, the number employed decreases. So at least that bit makes absolute common sense. The coefficient of x4 is negative and statistically significant. So as the number of people in the armed services increases, the number employed decreases. And then finally, the coefficient of x6 is positive. This suggests that the number employed is generally increasing over time. So just to recap then, the way this is written down nicely is the opposite way around to how we worked things out on the previous slide, and what you would want here is an interpretation element along these lines for any coursework or another year's exam assignment that I set. Okay, so this should be logically constructed, and the main aim of the game here is communication in plain English. So as the final last word then, so the previous slides details all the interpretation elements that would naturally be expected of you as part of the assessment for this module. Now that would be true for an exam in years when we sat an exam, and it would be also true for the coursework assignment that I will set. However, I think there's a sense that maybe a little extra needed for full interpretation of this example, and I don't want people thinking this is necessarily as nice and easy as you might imagine, even if you just need a relatively simple interpretation element for the coursework assignment for this module. I would suggest here that in this example the interpretations for x2 and x4 appear contradictory, and my suggestion would be the effect of these variables is dwarfed by the general increase in employment over time. So this is subtle, so again I think that the more realistic a data set you get, the harder the interpretation might be. I've had years of practice of applied statistical modelling as well as mathematics, so this isn't necessarily easy even for mathematicians. And the other thing I would say with this sort of deeper level of interpretation, because this time trend effect is so significant, you might reasonably question how likely this trend is to continue into the future indefinitely. So again, quite an involved interpretation once you look at it deeply enough.